Welcome, folks. This is our recording for Design 301. It's Tuesday, November 23rd, 1 o'clock. We're on Google Meet and the recording is running. As you know, this week is sort of an optional design work. I'll demo one with the recording. I've got some information for you here. So you get to just try your hand at doing some design work along with your CAD. Here's what a floating table looks like. It's very cool. Looks like, well, how does that work? How can that be? Well, it's really not that bad. The base, which you see right here. Actually, I think I'll put that on a Jamboard maybe. Then I can do a little bit better description of how it works. And let me see if I can find a Jamboard open somewhere. Here we go. Let me pop that up onto a Jamboard for you so that you can see what a floating table, how it works. Because it really is kind of a cool idea. It's kind of an optical illusion. But you can see that this part right here is solid to the floor and it's got a support. And so hanging on it is the tabletop. So it's fully supported. The table is being held up by this chain, which is being held up by this upper strut. And then, of course, it's attached to the legs. Now, you can imagine if you just tried to hang it there, this would flop over, right? It's not balanced very well. It could be, but as soon as you put anything on it, it would just go bonk and it would fall right over. So you need to balance it. And that's what these are. If I put a weight on the table on that end, it would want to fall over that way. And to do that, this end would lift up and try to curl over. That's how it would have to go. It would be like on this little circle here, right? And so as this tried to rotate, this would go up and over. Well, it can't because it's being held in place, being held down. So it can't, when I put something on the far side, this can't go up and over like that would want to do. Same if I put something on this side. It would want to fall down in this direction, but this can't go up and over. So, go. Welcome in. I'm going over how a floating table works. And so it's really a cool idea. You just need this upper support that goes on the base and a lower support that's attached to the top, and you hang it. And then to keep it stable, you just put some tension lines on. It's really a lot like a cable bridge design. You just see me. My microphone says it's on. And, oh, by golly, hold on. There we go. I'm sharing the screen now. I was recording the screen, but I wasn't sharing the screen. Thank you. And so these are just tensioners, and it really does hold in pretty well. So you've got an upper support, a lower support, and you just attach them to the table. So what I did, I just decided to draw one up. And so your goal this week, it's totally optional. It's only if you want to. Come on back on. There it goes. And dang it all, it left me high and dry. Means I have to open it back up. Okay. I did it in Inventor, so I'll open it up in it, but it doesn't really matter. So I just made one. And I gave you a couple of things. Here's how to make one, physically make one, how to go through the steps of building it. But you can see this one has 3 points. There's the lower, the upper, and it ties in at 3 points. So it's kind of cool. And of course, you need your little wires. They're not showing the wires very well. They're just kind of putting it there in space. Okay, but here you can see the little wires for it. Kind of a cool, neato design that takes a few minutes to figure out when you see it. So your goal is going to be able to do one of those. So let me open up my Inventor. And I'll go open what I made earlier today so that you can see it. And it doesn't matter. I don't care what well, what happened? There's my, oh, that's my 300. Hold on. There we go. So I made one of these, and I just made a simple part so that you could see what it looks like. And you get to use whatever drawing program or design program you like. I did one in Inventor so that you could see what it would be like if it was a flat plate layout. Isn't that cool? So it's a plate, and you bend the edges down, and you cut a little thing and you bend it, and here it is flat. And you can imagine that you could just go around that with your plasma cutter or your water jet or even a bandsaw if you wanted to. And you could cut these things out. And then these are what they call bend lines. So you could bend those. And if you wanted to, you could even make a drawing of it. Inventor is kind of cool because it automatically makes a drawing for you. There it is as a drawing that says bend those up 90 degrees. Oh, I didn't put a bend on this one. I better say what to do on that one. Bend up at 60, bend down at 60. Okay, so you can put those on there, and that's kind of cool. You can send what's called a DXF file to your burn table, and that way you don't really need all the dimensions. The only dimensions you need are something that might be used to check your part to make sure that it's okay. So I put in some things so you could check to see that it was okay. And so this is really cool. You can have your folded part, the flat part. Inventor is really cool. You get to see how to do that in Design 328. Okay, and then the other thing you can do is you can assemble them together. So I did it with 2 identical parts, and I assembled them, and you could see I would right in between these, I would run a cord or a chain or a rope, and that would essentially hold this in place, hold it up, and then between each of these, I could just run a cable or a chain or a piece of fishing wire or something like that. And I get to make 2 of exactly the same thing. And I can even, if I want to, figure out how tall this is. 17.5 inches. So if I want to make it a little taller, I can shorten up this distance right here. Or if I want to make it a little shorter, I can shorten that up. Now I can't go too far or it's not floating, right? So if I were to put this one on, see how I've inserted at 4? I could make that like 2. And then all of a sudden it's a different overall height. This is one of the cool things about Inventor. It lets you do a lot of neat things like that. So there we go. And you get to do whatever you want. You can make your design 3 or 4 or 2. You can make it out of one piece. You can make it out of many pieces. You can, just kind of play around with it. I even saw one that was really cool where they had sort of like a big column on the bottom and a small pipe, so like a pipe inside of a pipe. And they had sort of little things that you could hang it with, right inside the pipe. It was really a neato one. It was sort of like kind of floating there just on a pipe type thing. And then there were some of these. So many cool ideas. If you take Design 320, this is actually one of the items that you get to design. And we're not really doing much design here. We're doing a little bit of drawing. But when you do the 3D design after you've got it, we do a design review. And I'm not sure, Alicia, if you can figure out some of the things that you would be concerned about that we would have to look at. What do you think I'd need to check on this design to make sure it works? Got some good ideas?
I'm not really sure what I would look at to see that it would work other than just making sure that it was square.
Yeah.
But
So you've got that, but what if I put a 20-pound weight on top of that table and maybe this little tongue bent? I wonder if that would,
oh,
potentially that could happen. Or maybe this is a little bit too flimsy and I put something in the middle and it kind of warbles or something like that. Um, so, really, my main concern would be with the strength of this bend and whether this piece is strong enough or this piece. What if, it's like, hey, what's to keep that piece right there from bending and sagging? So, and there are design tools that you can use, and that's part of our Design 320. We don't really do an analysis of it, but we learn what questions to ask, so that when you move into other courses where we do the analytical tools, that you can do it. So, just for fun, I'll show you how we do it. Here it is right here. And I'm going to pretend it's the upside down one. And I'm going to do something called I'm going to do a stress analysis on it. And I'm going to create a study. And I'm going to pretend, actually, I'll leave it like, I'll pretend it's like this. And I'm going to pretend that there's 30 pounds of weight pushing down on that piece. So first of all, I have to make sure that I have a material assigned, and I don't, so I have to give it a material. What do you want? You want an aluminum, a steel, a stainless steel, a plastic? What's your fancy? I get to pick.
well, I guess is aluminum cheaper right now?
Um, yeah, well, right now they're all expensive, but we'll make it aluminum. That's a good one. And a 6061 is a very burnable one. I think I'd rather have 2024 on here, but they don't have it. If I wanted to
Oh,
make it, I could actually make my own material. Oh, there it is. Here's a welded 6061 welded. There we go. And then I have to say, where is it sitting? So I'm going to say it's sitting on the bottom. And I have to put a force on it. So I'm going to put a force on, oh, no, not there. There we go. A force pushing down. And I said it was what, 20 pounds, 30 pounds, 20 pounds. And now I've done everything I need to know to let it calculate. So here we go. Let's run a calculation. And then we'll just see if this is strong enough. So hold it. And if it's not, then I would just go back to whoever designed this. So 58,000 psi. That's getting up there for an aluminum. Let's see what the displacement looks like. It's going to move 2 inches. Almost 3 inches. And its safety factor, oh, it's got a terrible safety factor. So I'd go, I can't even hold 20 or 30 pounds with this. Okay, and you can see why. This is just a flimsy little piece sticking up in the air, and it probably needs some sort of a little support, right? Something to stiffen it, because this is like a really thin piece that's long, and it would, it would wobble. So we would go back to the designer and say, can you make this maybe a little more stiff? And you would think about all the cool ways you could do that. You could weld a strong back onto it, or you could weld a little corner tab here, or you could just make it thicker, right? You could make the whole thing thicker. Or you could even just put a pipe from like here down to here. You could just put a piece of tubing, bank, right on there. There's so many things that you could do to make this stronger, and it would depend on the aesthetic appeal of what the person was looking for, and maybe some material constraints. This is only 1/8 inch thick material, by the way. So it's really flimsy material. And then in Design 320, we would also ask the question, well, what else could go wrong with this? What's missing from this that most tables would have? Let's come back over to here. So here's a table, and I've got a base and a top, and I know I've got my little stringers. What's missing? Any other cool stuff that you would go, huh? Yeah, definitely not cat proof.
So like maybe a piece of shatterproof glass or whatnot, so that whatever doesn't fall down the strip.
Right. Yeah. Unless this was like a mailbox or something, right? It's like,
Yeah.
yeah, we would need something
So
to plug that hole, probably.
and then make it the corners need to be toe stub proof, a little more rounding, or
Right.
toddler corners.
Yeah. So this might actually be kind of sharp right here, right? Yeah. Especially this little corner, the upper part of the corner. Now, I did on my drawing say that this was supposed to be welded and ground. And you would probably be interested in seeing. Let me open the drawing. And are you familiar with some of the weld symbols? That's a flanged joint weld symbol right there. So you would grind that smooth 4 places. So they would just kind of like gop weld material into here and grind it. So yeah, so that's missing. Something to make this corner maybe a little bit nicer. What else would be missing?
So I think also the bottom needs a substantial weight,
Yeah.
so that not top heavy.
Yep. So you need something to, although it's pretty big, it's 36 by 24. So you'd have to really put and everything is weighted on top of this, so there's not a reason for it to fall over too much. But I'd be worried that this bottom is not flat, and so you'd set it on the ground and it would sit there, and you know how annoying it is when it's not flat and it just sits there, and every time you touch it, it kind of wobbles. So
Oh, yeah, so the little feet. I
yeah,
also see the design for me right now, that that little lip is a Dutch, dust catcher.
oh,
So
absolutely, yeah. This is gonna. So if you've got a cat, this is where all the cat fur is going to go, right? And probably for the strength of this is what's cool. Some of these are really easy to take care of. But watch this. This is going to be really cool. I'm going to start a sketch on this face, and I'm going to make a rectangle go, and I'm not measuring it out. And so now I'll just extrude that other way through all. There we go. Now it's not a Dutch catcher. Isn't that cool? And I could do the same thing over on this other side if I wanted to. And what's really cool is I'll save that and then come over here, and it showed up. Is that the coolest thing you ever saw? And of course, now what did we do though? We made extra sharp corners. So I can now put on here, I can put a fillet on some of these corners. You're going to like Inventor when you start playing with it. And I'd need to go do the other side. But now all of a sudden I've got much, much better corners, right?
right, much better corners, because I can see that you can't flip it over so that the flat side is up, because you have to have the holes.
Right.
But
Now, I could have, if I wanted to make two separate parts, right? I could have done a bend down on this one and a bend up on that one. So I could have, without too much trouble, made another one. But I decided I wanted to make it, mass
simple.
production wise, put two of them together and do it. And
Make it IKEA.
yeah, yeah, I wanted them to be exactly the same. Um, so, but it's not too, and look, see, you can tell that I made exactly the same part because it did it up here too, right? So
Yeah.
it put that in there. So yeah, so those are in Design 320. That's sort of what we do. We get going with sort of a design. We get the basic idea down. This would be called the what we started with would be what I call a mass model. It's just there to take up space and show kind of the idea. And then you just start doing reviews and start taking it little piece at a time. Now we might want to talk about, well, what mechanism will we use? Will I get a rope and just put a big knot in it? Or will I do some sort of a mechanism where there's an eye bolt and something, or a turnbuckle, or some fishing line, or so then you can start picking on this, right? I know there has to be some flexible cord between these two holes. What do I really want that to be like, right? um and you can start playing with that. Chain, a lot of people use chain for stuff like this. But then how do you tension these chains over here? How do you get them just right? Often you need a turnbuckle or something that's somehow adjustable, that's easy to do that way. So there's fun stuff. And so the process of design is to continually use refinement after refinement after refinement until you're not um, really making improvements, you're just making changes. And then you get to decide whether you're done or not. And usually you'll find that there are some criteria. So somebody might say, and this has to hold a 30-pound dog jumping on it, or a 20-pound cat jumping on it, or it's got to be able to handle a computer, a laptop, something like that. And so that would give you the idea of what the use is for it. It could be something that you say, and I need to be able to take it apart and store it and put it back together in about a 5 minute time. So a 5 minute assembly time. So different people will have different things that are important in their design. And that's what makes design interesting, is you can do it. And look, I'd even think that this is kind of ugly, and you might, if you're plasma cutting, put a cool design up here, right? A logo or a cool pattern like what you guys have been working with in AutoCAD, and you can put the pattern on here and then laser cut it out. That would be a cool thing to do. Lots of fun stuff. So this week, if you feel like it, absolutely not required, okay, totally optional, create a set of plans for a floating table. And the plans can be as simple as, where is mine? Let's see. It can be as simple as, well, this is not as simple as it might be. But it could be like this top view, or it could be just something like this, or even a front and a side view. Let me see if I can move this down here, and let me put in place view. Could just be something like as simple as that, with a projected view as that. It could be as simple a drawing as that, with a couple of dimensions on it. There's my annotate tab. And there's all sorts of things that you can do and change. But now I've got my full, everybody kind of knows how big this is. Right? And I could even maybe put a dimension between these. So that somebody just has a basic idea of how this thing is built. Something very simple. Okay, so you don't need all this other stuff. You don't need flat plate layouts and detailed dimensions and things like that. This is like this would be what I call a mass model design. Very simple model that gives you the idea, that gives you the basic size dimensions and sort of how it goes together. Cool. And then if you want to add other stuff, you can. It's totally optional. It's just for fun if you feel like it. There's no submittal. No submittal required. You want to keep it for, a very nice portfolio or to play around with it, that's cool. More than anything else, I just love the idea of how does one of these things work? When I first saw these, I was really scratching my head because it does look like it's floating because we know that these cables are very flexible. But since they're all in tension under load, it works. Tension, 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 tension. And the reason it's in tension is if I put a weight on the corner over here, it's going to want to tip and spin. And for it to tip and spin, this end has to go up while this end goes down. And it can't go up because of the chain. So that's how it operates. Very, very cool how it works. Cool. Any questions about this week's totally optional assignment? All right, then I'm going to turn off the recording